In this video, we create a harness for the driver's door based on the wiring design we created. Right mouse click in the project browser to create the new harness design. Give the design a part number and the new diagram is displayed. We have the option of defining either dynamic or static bundles. We choose dynamic bundle, which draw to scale. We can zoom in while creating the bundle, and when we're happy with the length, 300 units, we double-click to create the first bundle. The harness must connect through the inline connector C_IL1, so we create a connector at node 1. In the dialog that opens, we define the connector names as C_IL1, and in the attributes table, we set the number of cavities to 10. A default symbol is placed and a default cavity table is also created. Currently, these are the only two objects in the harness design, a bundle and a connector. We could continue to build the harness design in the same way, but a faster way is to use the information already defined in the wiring diagram. This saves time, automates a process that can be very error-prone when done manually, and ensures that both the wiring design and corresponding harness design data is properly synchronized. To support the synchronization, we need to provide library definitions for each connector in the wiring design. The door lock switches are 3-pin connectors, so we right-click to show properties. From the Library Part panel, we click on Add. And from the Part Selection dialog, we click on the search icon. We select the 3-way blue connector, click on Insert, and OK the remaining windows. Notice in the design browser, there is now an orange checkmark icon beside the connector. This means there is a library part definition attached to the connector. The two switch connectors both have 2 pins. In this case, let's say we know the part number it is, C-71332. As we manually enter the part number, we see the system filtering down the information. And when we come to the last stage, we select the part, click Insert, OK some default information for the 2 connectors, and we have got library part definitions assigned. The inline connector that connects the driver's door harness to the rest of the car has 7 pins defined in the design, but we want to use a part that has 10 pins. So we search again, and this time, because this part number of pins is 7, the system returns all the connectors with more than 7 pins. We select the 10-way green connector and OK the default values provided in the dialog to complete the library part assignment. VeSys performs a series of checks on the designs before it performs the synchronization between this wiring design and the harness design. If any problems are found, it provides feedback to the user on how to correct the data, as we shall see in the next few steps. Notice that except for the connection and the bundle, our harness design is empty, and we will see how the system responds as we do the synchronization. To synchronize the wiring design, we right-click, select Synchronize, and the system tells us the harness design needs to be saved. So, we save the harness design and try again. This time, the system tells us that the wiring design needs to be saved and closed to ensure that another user is not making changes while the synchronization is made. We close the wiring design and return back to the harness design. We try again. Earlier, we had set the harness name in the wiring design to Door-DR. But our harness design is called Harness Design 1. Let's fix that and change it to Door-DR. With all information properly set, we can go ahead and do the synchronization. When synchronization is complete, you will notice that the cavity table is populated with wire information. The wires have come across, and we also see that the connectors and splices have come across too. We can open the message area and get a detailed report of the synchronization. At this point, we want to position our connectors so that we can route bundles to them. we click the black structure node and reposition the connector and repeat for the other connectors. For splices, we select the splice, drag it close to the bundle, and to place it, we can click on it, select Move, and locate a point on the bundle. The node position utility pops up where we can make changes, but for now, we just say OK, and we reposition some of the connectors so that we can route bundles accurately. We will use static bundles to connect each connector to the main bundle. These are unscaled, allowing you to define the length interactively, but in this case, we'll simply accept the default scaled values. For the rest of the connectors, we will time-lapse through, and where the node utility pops up, we will simply accept the default values provided. To place a splice on the bundle, we can select it from the Design Browser tree, click Move and locate a point on the bundle, and OK the Node Position utility. Alternatively, we can select the splice from the diagram, right-click and select Move, locate it again on the bundle, and accept the default node position values.